All right, great. Well, again, let me welcome everyone, all the attendees here this afternoon to today's version of Bayyinah and Friends. It's a series program that we started last week where Professor Bayyinah Bello invites a special guest to interview, have a conversation with, or send a shared message with. We tried, so far we've been doing it on a weekly basis, but whenever we get a special guest, we'll program and have a nice little interview session. In this instance, we're going to be doing different types of experiments and connecting science with all the things that we've been talking about. So I'll pass it over to Professor Bello to introduce our guest.
Thank you, Franz. Welcome, Kim Magloire, to Fondation Félicité, because everybody who comes to Fondation Félicité virtually. And Kim Magloire is an epidemiologist, but more than that, Kim is someone who's really concerned about our children's attitude towards science. She feels that the way it is often presented makes our children afraid of it, feeling they are not good enough for it, and things like that. So Kim has created Sci-Tech, which is a place where children can come and learn a lot, experiment, touch, do things, and be more aware how much science is part of our life. So welcome, Kim. And
thank you.
Go ahead and do whatever you want to do for us right now.
Okay, I'm going to start first, talking before I start with the experiments. I'm a biologist and an epidemiologist. Epidemiology is what I studied in graduate school. And I always had a love and a passion for science. So for me, it came very easily. And for me, it came out of curiosity, a lot of the why. Why are we the way we are? Or why does this happen? And I wanted to figure out how to answer those questions. As I got older, though, I saw that there were a lot of people who felt science was challenging, especially the studies now show it used to be in high school is when you experience science when it was difficult. But now it's as young as 3rd to 5th grade. The kids say it's like a different language. It's not fun. There's a lot of memorization. And so by then we're already starting to see two things, either students of color in particular who may not find it as interesting, and then girls. So a lot of the girls get turned off a little older, 5th, 6th, 7th grade. To these topics. So one of my missions, or one of my goal is to make sure that people relate it to everyday life. So I tell students, how many scientists are in a room? Or how many people love science? When they're young, everybody raises their hand, especially when they're 3 to 5 years old, maybe 6 years old. Suddenly when they're in school, which means the school system has had an impact. So how many people love science? You see a few hands, or they tell you what type of science that they do like. If you ask them, can you draw a scientist for me? 99% of the time, it's a white gentleman, gray-haired, in a lab coat, kind of like what I'm wearing, but not necessarily having fun. So, if people at a young age already have that impression, how can they see themselves as scientists if that's not what they even draw? So a lot of these things, I believe, have to be tackled early when they're young, so that they're not tainted. So for example, with the kids I work, I work with kids as young as 3, and I can tell you, if I have them for 2 years, by the time they're 5, the things that they will tell me, when they go to school, they call me Miss Kim. So they'll say, Miss Kim, science in school is not the way you do it. It's not as hands-on. It's a little more serious. There's no snack, because we always give snack as part of our program. So that's obviously important to them. But then they say, they don't let us talk. They do all the talking and we do all the listening. And so it really is nice when they get to participate and even have their questions answered. So if you keep telling a child, don't ask questions, we don't have time to answer that, they stop talking, they stop thinking, they just want to memorize and give you the right answer, and then later on, you wonder why they're not creative. So it's no wonder that in elementary school, the damage has already been done. So my philosophy is we need to start them early. I tell them that they should be scientists now. If everyone's a scientist. If you cook in a kitchen, you're a scientist because you're mixing ingredients and you want to see the outcome. If you're, exploring, looking at things in the park, we take our kids to Central Park and we have different activities we do with them. Then if we're exploring the water, then maybe you're an oceanographer. Maybe you're, we study insects. So they are taught that they can be any of these things now, even without all the scientific. Because the most important thing is the question. And last, before I start an experiment, the philosophy that is predominant in my world, the approach is called STEAM, not STEM. So it's science, technology, engineering, art, and math. And we add the art because the art actually allows them to be more creative. So when I say to a child, what kind of phone do you like? What kind of phone do you have? Most of them will say, the iPhone. I said, is the iPhone better than the other phones? Kids will say, yes, because more people buy the iPhone. I said, that's not necessarily true. Components are the same. Why are people buying the iPhone? They go around and they start talking and they figure it out. But then I said, of course, it could be marketing, but more importantly, it's the A, it's the art, it's the design behind it and how it's promoted that makes people feel this phone is better than another phone. But as far as how it's engineered, it's probably not that different. And so the A is what makes something more attractive or unique. And so the more of that we incorporate, we're finding that students who have that either artistic ability or who incorporate that ability, all the other things they have to learn is more palatable. So they're able to hear it when they're still allowed to put their own creativity or their own spin to it. If you just say we're all going to do the same cookie cutter project, experiment, and it has to be identical, then it looks like there can only be one winner. Suddenly, when you have each child adding their own spin to it, everybody can be a winner. Everyone has something to contribute. Everyone has something that is unique. Any questions or anything yet? Or Bayyinah, did you have any point before I do an experiment?
No,
Okay.
it's clear, and I appreciate in particular the art, that things are not put in opposition to each other. Art and science work hand in hand, one complements the other. So that's a very important point. And yes, please go on. I'm eager to see.
Okay. Okay, so I'm going to start with a very simple experiment. I tried to pick things that you could do at home, or if you have a child in the room, you may want to bring them so they can take a look. Because if you are in lockdown the way I am in New York, the more activities that you have or the more creative things that you're exposed to, the better. Because it's a lot of time and a lot of hours to be with kids when they say, what's next? Or the expression I was not allowed to use growing up, I'm bored. We were not allowed to use that expression because we were told that there was always something to do.
Mother wouldn't go for it.
No, books in the house, so I think kids are easily bored because of electronics. Not so easily bored when they actually have something that is what we call in science open-ended versus closed-ended. So you buy a robot, you push the button, you know how it works. After a few weeks, the child is not interested. tell a child to design a robot or to do something else with it, they can do it for hours because they're adding, again, it's open-ended. It doesn't have just one solution. Okay, so I'm going to start with the first experiment. Me? And can everyone see? I'll even bring it forward.
Right.
So I have here a test tube holder and 3 test tubes. So now I'm going to bring an ion, perfect material. You know, scientists, we talked about materials. So I'm now going to pour this solution into all 3 test tubes. While I'm pouring, I want you to try to guess what that solution is. And my goal is to make them look about the same level. And I'll tell you in a second why. Okay, so can someone tell me what they think I've added to the test tubes?
Water.
Very good, I added water. Now, how do you know it's water though? That's our natural guess, correct?
Because it's
But guess what? There are a lot of chemicals in science that look like water that are not water. So you do want to be a little careful. We have a lot of kids to come to our facility, our space, as we do birthday parties. And when a child walks in late, sometimes they see something and they go, oh, I'm thirsty, and they want to drink it. They don't ask, by the way, what is in that test tube? Sometimes they get a surprise if they were not, we were using, that it was not water. But yes, this is water. So now, I'm now going to add this solution to one of the test tubes. And what do you think this is? I want some guesses. First of all, what's the color?
yellow.
It is yellow, very good. And what do you think it is? What do you have in your home? Remember, everything I'm using today is something you can find in your kitchen.
Blue.
Called it, excuse me?
Oil. Oil.
Very good. It is oil. Okay. Now, but here's the hard question. And I don't want the kids to answer it yet. I want the adults to answer it. When I pour this oil into one of these test tubes, which one do you think is heavier? The oil or the water? If the oil is heavier, it's going to sink to the bottom. If the water is heavier, it's going to remain on the bottom. So let's figure out.
Water is heavier.
So I have one person who said water is heavier. I need somebody else, another guess. Remember, this is oil.
Oil.
Oil. Okay, so let's see. So I'm going to pour it.
You can watch them go.
So what did we learn?
Oil is heavier. Oil is heavier.
Water is heavier because it's on the bottom, and to make sure you can all see, I'm going to lift it out of the test tube holder. Do you see the difference? So the water is clear and the oil is clear. So now I'm going to actually pour it into 2 of these. Okay, and before I do that, I'm going to let you see what happens to this, and then I'll show you what happens with the other one. Now, why do some people guess oil, by the way? Oil is thick. So a lot of adults, not just the kids, think that oil would be heavier, but it is actually lighter. And if you use other forms of oil, like lamp oil, it's even lighter. So now I've got water, I've got oil. The word that we would use for this is density. Density means, so water is more dense or denser than the oil. Now, to make this, so far, this doesn't look very interesting, correct? We're going to make it a little more interesting by adding food coloring. And I'm going to let the kids choose. Which one would we like to use, red or blue?
Blue.
Okay, so I'm going to add a few drops. 2 drops. Now let's see. Can anyone tell me what's going on with that food coloring?
Turning blue.
See, is it turning blue or do we see blue drops in there?
Blue dots in there. Yeah.
Yes, and notice, I'm not sure if you can see from where you are, but I see 2 drops at the bottom of the oil, and then there's still 1 drop hanging, can you see? Hanging in at the top. Okay. So far, the fact that, can somebody tell me what food coloring is made up of?
So if we got food,
Do you think food coloring is made up of water or oil?
Oil.
Guesses? Food coloring, do you think it's made up of water or oil?
Oil.
And why would we think oil?
Because
It's not as dense as water.
Because it's not moving down yet, correct? Look what's happened already.
Now it's mixing.
oh,
So it took a while for it to travel, but it's mixing already. Interesting pattern. It usually doesn't look like this into the water portion. But wait till you see what I'm going to do next. I'm going to take a tablet.
so
I'm going to break it up into pieces.
the oil going into the water. It's not
I'm going to add the tablet to the water oil solution. Let's see what happens.
It's out of the camera.
Out of the camera. Come back. Right. Okay.
So what's going on?
it's bubbling.
It is bubbly, correct?
Yes.
Now I'm going to add a little more. Someone tell me what they see?
Bubbling.
More bubbles, and if you could hear it, it's actually getting very loud. And it's starting to look like a tornado. Can anyone see that?
Yeah.
And the bubbles are getting big. See, sometimes you'll see these big balls.
What
I'm
kind of
gonna
powder
add
was it that you put in there?
Alka-Seltzer.
Alka-Seltzer.
Now I'm going to add a lot more so you can see. Now, if you were here, what I would tell you to do is put it to your ear. You would not only hear it, but sometimes, depending on how much of it, it actually tickles your ear because it's fizzing so much. But now I'm going to put it back in the test tube holder. Now, why do you think we have a test tube holder? What's the function of this?
Because the bottom of the cup is like circly, and if you just don't have the holder, it'll fall.
Very good. So the holder is to keep it in place, and so it doesn't spill all over the place. Okay. Now let's look what's happening. Can someone describe to me what's happening now?
It's different colors.
Right. It's different colors because what has happened to the solution?
At the bottom, it's bubbling. At the top, it's white.
The top, it looks whitish. It's actually still yellow. So the oil and the water are separating. So more of the oil is on top, the more of the water is on the bottom, and it's slowing down. Are we seeing the activity that we saw before? Is it moving as much as it was before?
My screen is so dark, I can't really tell, but
No, it is not.
tell that it's darker. You know, the bottom part is darker.
Right.
Mhm.
Now, the reaction has slowed down. So this is what they call a chemical reaction. And what that means is something was mixing and it's transformed. So now I'm going to tell you what it was. The tablet is Alka-Seltzer, and it looks like this. And I'm sure in most homes they have it. If not, it's one of those things you may want to test it again with your kids afterwards. And when this tablet mixes with the oil water solution, it produces carbon dioxide. Who can tell me what carbon dioxide is? Is it a gas? Is it a liquid? Is it a solid?
Carbon dioxide is a gas that
Yes.
after we use the oxygen in our body, we turn it into carbon dioxide and send it to the trees.
Mm-hmm. Very good. So carbon dioxide is what you exhale. So when you breathe in, it's oxygen. When you breathe out, it's carbon dioxide. Okay. So now, what do you think is going to happen what's going to happen if I add more of my special Alka-Seltzer?
Could blow up.
I like these chips. See, there you go.
It starts the reaction again. You see that? And it probably happens a little faster. One, I put a bigger piece, but also it had some chemicals to begin with.
How come you like
Now, here's a good question. Can someone tell me the difference between a demonstration and an experiment?
Demonstration and an experiment. What is a demonstration? What is an experiment?
Okay. So most people think anytime you're doing anything like this, it's automatically an experiment. The way I like to describe it is a true experiment is when you're doing something either repeatedly to see if it's consistent. So if I do this over and over again and leave it as is, I just want to see if it's consistent, that could be an experiment. But if I just do it once, it doesn't necessarily mean it's an experiment. Two, when I change one of the conditions, that's when it's an experiment. So for example, let's only add water. So it's at the same level. I'm still going to use the same color. And I'm still going to add the same tablet. But what is the one thing I did not add that we added before?
Oil.
Oil. So let's see what you predict. What do you think? In science, we call that a hypothesis. What is your hypothesis about what's going to happen when I add this to the solution? And the best part, this is the part I like about science.
Sometimes your voice goes too low.
Oh, really?
The end of your sentences are missing.
Okay.
Mm-hmm.
So if I add this tablet, one of these tablets, what is your prediction? What do you think is going to happen in this test tube compared to the first test tube?
It's gonna overflow.
Say it one more time.
Overflow.
Overflow. Okay, let's see.
No, it's just bubbling. Yeah.
So now, how is this different from this one? What do we?
Oh.
So notice he is right that are you seeing the very big bubble at the top?
Mm-hmm.
Yes.
So the water and the Alka-Seltzer, you definitely see the chemical reaction, but we didn't see the beautiful ball. You don't see the separation between the two. So we know that water and Alka-Seltzer is what makes the reaction, but we don't get to see that bubbling lava lamp, the difference between the two. So which one do you think was nicer, this one or this one? First experiment, the first activity or the second? Most people prefer this one because you get to see a lot more activity than this. So a scientist would start writing up what happens and compare one to the other. So one would be considered a control, which means the conditions are all established. And the other one, they usually change one thing, because they want to determine what happens. So I'm going to give you an easier example. I'm going to put this down for a second. If I have anyone make this approachable, how do we know that water is critical to plants growing? How would I design that experiment? I'm going to start it, and then I'll let you add to it. Rule number one, a scientist would say, we need two plants that are identical, same size, same type, because we don't want that to be the factor or the reason that they grow differently. So what else would I do to make this an experiment? I want to know if water is important for a plant to grow. What would I do?
You would water one and leave the other?
Correct. Water one and leave the other. If I wanted to know if it was sunlight that was critical, what would I do? Somebody else. If I want to check if sunlight is important for a plant to grow, what would I do?
You expose one to sunlight and the other one you keep it, let's say, indoors or away from sunlight.
Exactly. So that's what science is really about. They want to check to see if the conditions are the same, except for one thing, we are closer to finding an answer in terms of the why. Now, we know that it's not just water and it's not just sunlight, but that would be one way we would look at those conditions. Now, here is another one. Do we need, you may know this already from experiments you may have done or what you read about. Do plants
You
need,
breaking up? Would you repeat, please?
okay. Can you tell me, do we need soil in order for a plant to grow? Let's think about that. Do we need soil in order for a plant to grow?
Yes. Yes.
I say no.
Well, we could do it, except we're not going to do it here today, but I would advise you to take a plant, those of you with your kids at home, put one in a cup in just water and leave one in soil. You'll be shocked, soil is not required in order for a plant to grow. So why do we use soil? For most plants, it's not a requirement. So why do we use soil? Why is soil used for most of those conditions? It's to give it structure. But hydroponics is when you grow a lot of plants in water and there's no soil. So you just have to add the nutrients to the water that the soil would have, but you can grow plants without soil. Okay, does that make sense?
Sound exciting.
Okay, so you should try it because it's there are parts of the world like in Israel, in rocky areas where they do not have soil, or in countries where it has more desert. They've had to figure out how to do that because they need to grow without having, any soil. Okay, are we ready for, instead of I'm going to switch now for a different kind of activity. This is not an experiment, but it's actually fun. So I'm going to start it, and I want the kids to participate especially, but then I'd love for you to continue this at home. So a lot of you may have, do people have any candy at home?
Yes, everybody does.
Okay, especially in New York, a lot of people bought candy for Easter. And since if you were on lockdown, then you were not doing any Easter egg hunt and all of those things, or people buy a lot of that for schools, and if the schools are closed. So I know a lot of people who've said to me, I have way too much candy in my house. So I tell them, why don't you use them to do science activities? I'm going to show you my favorite one. Okay, I'm going to use this tray just as my holder. And I'm going to pour some candy, and then I'll show you. What do you think these are?
We can't really see. All right.
Is that like sour candy?
Gumdrops.
Lemon drops. Oh, gumdrops.
Or the sour ones are spice drops if they're smaller. Now, in my classes, usually I like to use the small ones because they tend not to eat them while we're doing the experiment. Unless you have kids who say, well, I like spicy food. So that's not an excuse for them to not do it. Now, is anybody here into engineering? What does an engineer do? An engineer is someone that solves problems. So that's the general definition of an engineer. So if you're one of those people that likes to solve problems, you have an engineer type of mind. So what we're going to do today is prove a point, and we're going to design a simple bridge that I'd love you to do on your own afterwards and try it. So I have only two materials, the spice drops and what are these? Toothpicks. Okay, so spice drops and toothpicks. So I want to design a bridge, but most kids, when I say that, they just want to take the spice drops and they start doing something like this.
Some more.
Okay, so they start building something like this. But before we do that, there's a rule in engineering, especially if you want to be a civil engineer. A civil engineer is someone that designs bridges. I'm going to ask you a question. Which shape in nature is the strongest shape? What would you guess? Which shape in nature, in most
Straight line?
Triangle, pyramid, and my daughter said circle.
Circle is a good one. I heard
said pyramid.
somebody else said pyramid, I think.
Yeah, I'm saying pyramid. Her mom, she's saying circle, my daughter.
Okay. Anybody else?
Straight line.
Somebody said straight line. Anybody else? One, a little louder. Triangle. Okay, so we're going to prove a point. We're going to do a few of these shapes. So I'm going to start with a square, since I already. So, everyone see this? Can everyone see the square?
Yes, we see the square.
Okay, so now I'm going to lift it up in the tray. And I'm going to apply pressure, and I want you to see what happens to the square when I put my finger on it, okay? What happened to my square? It starts to bend. It starts to deform. So the square is not the best shape. So I'm going to try a pentagon. What's a pentagon? How many sides does a pentagon have?
6.
Close.
5.
5. Very good.
5.
Does everyone see the pentagon?
Yeah.
Okay.
3, 4, 5. Yes. So then the house they call the Pentagon.
Yes.
Does it have 5 sides?
Some parts of it have, but not completely.
Okay.
Now look what happens. If I take my finger and I press.
Can you hold it up a little bit higher?
I'm gonna put it with my hand. How's that?
Higher, please.
Higher.
Higher still.
Yeah, there you go.
Okay, now we see the whole thing.
Okay, so now I'm going to press. Unfortunately, what happened?
It broke.
It broke. It also became deformed. When I'm in my class, usually the sound I make with this is quack, quack, quack. Didn't work. Okay. I'm going to go with a 6-sided figure. What's the name of that?
It's a hexagon.
Very good.
Very good.
Have some geometers in the room. Go into their geometry. Good.
No, you can take it. No, I gotta take the Lexus. I gotta take the Lexus to
Anyone see?
Now, higher, please.
Okay, let me just put that back in.
Is there a way that you can put the camera lower?
Let me see.
Yep.
All right. Yes. Mm-hmm.
Okay, so now it's actually easier when I use my smaller spice drops. But I'm going to hit the orange piece. You want to see that? And press on it. Again, do you see how it forms?
Yes.
So we're not going to do any more of these because I think you're getting the point. So far we did 4 sides, 5 and 6. And it became weaker each time. So now let's try the triangle.
She want the guacamole?
No.
Yeah.
Bring your hand in.
Want to see it?
The triangle, yes.
So now I'm going to put it in the, no, I'm going to just keep it in my hand. It'll be easier. So when I apply pressure,
Higher.
it doesn't deform.
Uh-huh.
But can someone tell me why? Now look at that shape. We have 3 sides, 3 angles. When I apply a pressure at the top, for example, but it could be at any of the sides, but you see it best at the top, the pressure gets split between these 2 sides. You see that? So it's evenly split, so it doesn't deform in the same way as the other shapes. So if you're looking to be an architect, an engineer that is designing or building things, they tell you you need to know that the triangle is the strongest shape. We're talking about upright. We're not talking about horizontal. Okay. So how does that help us?
The shape of the pyramid.
Exactly. So that's why a pyramid is a 3D form of a triangle. You can have a square base, or you can have a triangular base to form a pyramid. And so once kids get that, when you understand that, most people, they're not even taught that in school until they get to high school if they're lucky. Or most of my instructors, they learn it their first year of college. This is what they call engineering 101. Something that we should teach to children as young as 3.
Yeah.
So now, how would I go about and change this to a bridge? All you have to do.
I know what you gotta do.
Tell me what you think I'm gonna do. No? Everyone see what I just did?
Yes,
I made 2 triangles, and then the base is a square. So if I want this to be a bridge, I can make this a very long extension.
Can you hold it up a little higher? Oh, there you go.
So this is the beginning of a bridge. And when you do a good job, when we do this, if you want to do this with older kids, or if you have a hot glue gun, same concept, same principles, you can do this with popsicle sticks. And if you apply it correctly, there's a mathematical formula that if you do this correctly, you can stand on your bridge like a chair, it will not break. So kids who come to our class that are 9 and up, they spend 3 weeks designing it. And the last day, everyone's standing there going like this, hoping that their bridge will not break. And usually it's either none or only one. And then the other kids have to help them fix the bridge so they can have a workable bridge when they take it home. So understanding the math behind it is critical to making sure that it works. But even with this, to make a point, let's see if I have one handy. What I usually do, I think I do. Everyone can see the bridge?
Yes.
And if you've done it properly, you know, you play with it a little bit to make sure. You can balance a book on the bridge.
I see.
Oh, nice.
Right. Bravo.
Wow, nice.
So imagine, so when it's the simple form, you can show them that it's strong enough to hold books. And what we do is we pile different books on top, depending on how well they did them. So now here's a challenge. I'm going to start with, well, anybody can answer this question. Stronger. I want to see who has that mathematical mind. How can I take this and make it stronger?
By putting turning those squares into triangles, 2 triangles.
Very good. So one answer, everyone heard what she said? I could take my toothpick. Now I'd like the kids to answer, not the adults. How many triangles do I now have? This is 1. You want to see it?
3.
This is 2. And then now I'm going to flip this over. This is 3. And this is 4. So 1 square can be divided to make 2 triangles. So that's 1 step. Can somebody tell me another thing I can do to this to make it stronger? How can I make this triangle, this bridge, a little stronger? Okay. How about this? I'm going to take what Professor Bayyinah said and make a second. I can do that. So now, how many triangles have I created? On the bottom.
4.
Exactly. 1, 2, 3, 4. What's another way to strengthen this bridge? I can take my toothpicks and double up.
Right.
So now when I hold this, it's even stronger. So that's where I'm going to put my book. If I have to choose which one I'm going to emphasize, I would reinforce the top. Okay, so there are a lot of ways you can think. Now, what I do to make this mathematical in my classes, I charge you to make the bridge. 10 cents for the big gumdrops, 5 cents for the little spice drops, 2 cents or 1 cent for the popsicle sticks. So I give everyone a budget. So you can go crazy and make your bridge, but you have to come within your budget. And so it helps them write down and figure out the math, and it makes them choose or to think wisely, because a lot of people can design something that's very creative, but in the real world, what happens? Someone has to pay for it. And if the city of New York says we're only going to spend $1,000, then you have to make sure that you can build a bridge that's $1,000 or less. So sometimes there's a lot of good or creative reinforcements. You want to be able to think about that. Okay. Before I move on to a third one, I'm going to show you how many kids in the room or people in the room have seen or worked with a 3D printer. What is a 3D printer?
We have.
A 3D printer is a printer that prints an object in 3D form.
Yes. And what is it used to do that?
I don't know.
What kind of material?
Plastic. What was it used? The printer.
Yes, most people use
Plastic.
So for example, I'm going to show you some things that I've 3D printed or somebody in my staff. What is this one?
Martian.
A Martian, a robot, right? So this one is 3D printed, and I know you can't touch it, but if this is light, because it's hollow. So the inside is not 3D printed, it's just the outer part. Now, here's another one. This is a 3D printed object. Now notice, the material looks a little different, right? The shape. And then I just took mine off my hand, printed this. What is this?
Round.
Bracelet.
It is a bracelet made out of metal. Okay? So we have people who 3D print plastic bracelets. This is one that I just put on my arm like this. And we have a mannequin here at Sci-Tech, and the mannequin wears the bracelet to match all the other things that she's wearing. Ah, I like, can you hold that up? I like what she's showing me. Very nice. How long did it take you to 3D print that? How long did it take you to 3D print?
It was a long time.
Okay. Okay. So now, I'd like to ask the younger generation first. What are some of the things that you think you will be 3D printing as you grow up? Because the 3D printer is something that's going to be very common, very small, very efficient over the years. So what are some ideas? I want to hear what you want to 3D print, and then I'll tell you what I want to 3D print. Then we'll also ask the other adults in the room what they want to 3D print. So I want to hear the dreamers. I'm sure there are a lot of dreamers in the room. What do you dream of 3D printing?
Heart.
A heart? A heart as in like Valentine's, or a real heart? A little louder.
Valentine's.
Okay, so she would like to 3D print a heart like for Valentine's. That's easy. You can do that anytime. Okay? But I want to hear other things.
I want to 3D print a house.
Ah, you're a girl after my own heart. That's what I'm going to do. There are already companies that I know of that are 3D printing houses, and nice houses. One of them, that company actually 3D prints house in Haiti, by the way.
Wow.
I want to see where, I don't know the town. I have to ask what town it actually has 3D printed the house. But in Austin, Texas, that house, they built it for $10,000.
Wow.
Beautiful house. Small. It was for low-income people, but especially looking at what happens when you're under lockdown, I would like now to have a house that is fully paid and solar paneled so that I don't have stress. And I can choose to hang outside without anybody telling me you can't go outside.
What's that? I would 3D print a cell model so that people can, teachers can like demonstrate like cells when they're teaching that and like show where everything is.
I love that answer.
Mm-hmm.
So I'm gonna show you something. So for example, when I work in some schools, and we're talking about the environment, this is one of the things we 3D printed, talking about geology and what happens to the earth over time and how glaciers are formed. So this is one of the things we 3D printed for our class. It could have been a cell, it could be anything. You're absolutely right. Just learn the size that you want.
Is it possible to ask you a question?
Sure.
Okay, I'm sorry that I'm blocked out, but my daughter is about 15 years old, and she has had an interest in forensic science since 5th grade.
Okay.
What just because she's gonna go a bit, but what like pointers would you give her in that aspects? Because a lot of the sciences right now don't gear towards what she's looking to do.
Okay. What I would suggest, where do you live?
Norwalk, Connecticut.
Norwalk, Connecticut. Okay. The first thing I would do is go online and check to see type forensics for kids and find out if there are any after school or summer programs, or there's usually some club that does forensics for kids these days. If they don't have it, then the second thing to do is look at forensic courses that are available online. Ever since CSI, all those TV shows came on board, there is a lot of forensic groups or activities. So that would be another one. And third, contact the universities. So every once in a while, I'm in New York, so I used to do talks at or programs at well, now it's part of NYU. Then it was called Polytechnic University. And we would do forensic classes or activities for free. So we would have twice a year, we would invite kids to the program and they could choose the room. So one was a forensic room, one was a microbiology room, one was so they could rotate throughout the day. And the class, when I did the forensics, we would have the room taped up as if there was a crime scene. So from the minute they walked in, they had to learn all the skills. How do we solve this crime based on the evidence in the room?
Oh wow, that's amazing. Thank you.
So those are the three things I would do, and you'd be surprised, especially with the university, the ones that are free. They don't do it all, all the time, but they would definitely have.
I appreciate you. Thank you so much for answering that. Thank you.
Oh, you're welcome.
I appreciate it.
And that's also a very good growing field, because the technology that's coming in for that, you can do forensics now using your phone. They're able to, everything is getting smaller and smaller that you can actually do forensics without carrying a lot of material. They don't have to wait to go back to the lab. They're going to be able to collect the data and to analyze it in the room. So if she's into that, that would be a great field to be in moving forward.
She's searching right now. Thank you so much.
You're welcome. Okay, the last thing I was going to show you, who said a heart? This is one of the first things I 3D printed. It was something I did for my friends for Mother's Day. So it's a vase, but on the bottom, what's the shape? See the heart?
It's a heart.
And then a completely different shape, just a shape what 3D printers can make, things like that as well.
That is amazing.
So is it a special software that comes with the 3D printer where you have to like design the object?
Well, there are what I call the classic software, Tinkercad is a software. There are a number of them, but some of them, the cheapest, easiest, I have expensive 3D printers and I have very inexpensive ones. Because when you work with kids, somebody bumps into it, somebody knocks it down, and I want them to have access to it and not to be afraid of it. So that company is called XYZ Printing. You can get an XYZ printer for under $200 now. And so they have their XYZ software. So if you actually use theirs, you design it, feed the information to the computer, you're done. But it's a great one. I mean, it's not as great as obviously some of the other ones, but for an intro, if you're looking to try it, but that one works best. It will take other software as well, but it comes with its own, which means that it makes it easier to learn. But that one is called XYZ Printer. They even sell it at Barnes & Noble. Sometimes Barnes & Nobles will have it on sale because Barnes & Noble twice a year does a STEM or STEAM activity. And so they want you to buy things there, so they'll sometimes sell it at a discount.
Awesome, thank you.
Yep. You're welcome. So let me move on to one more experiment, and then we can do a little more talking. Before I do that, I just wanted you to see what 3D printing can also do. This is 3D printed using sandstone. So when you touch it, it looks like sand. And one of my friends, let me get that for in a minute. Let's see if I have it handy. One of my friends, his company, even though it recently closed, he would take something like this. You could send him a picture and he would automatically convert it to a 3D printed object made out of sandstone. So if you have a child that's very artistic and you wanted to have a keepsake, you could make it 3D. And that was really, really interesting the way he would do that. But so the last two things, my last one, I'll do a chemistry experiment, but before I do that, can anyone tell me what this is? Tell me what it is and what it's made out of.
A launcher.
Like a
Very
catapult.
good.
Made of popsicle sticks.
A launcher, they call this a catapult. What is a catapult? And when were catapults very popular? Any ideas?
Back in the ancient days when, yeah, that's all I can say.
During medieval times or ancient times, yes.
Yes.
So when people had castles and you were afraid someone was going to invade, you would build these walls, and other people would also build these launchers. So what do you think they would put in here?
Rock.
Rocks or whatever, and they would start launching them to try to, when they say huff and puff and blow your house down, well, the launcher or the catapults were ways of doing it. So it's another great thing. If you Google and you just type catapults and kids, you will see every kind of shape. This is one that one of our students left here, but this is not even the typical one that we make. But the whole point is you need to understand, have enough tension so that you can, using the rubber band, launch something across a room. For parents, if you do use this, what I recommend that you launch, marshmallows. No damage, really easy.
I need that in my life.
Excuse me?
Very good advice, thank you.
That's okay. So we have we have events here where everyone's designing them, and then you just see all these marshmallows floating all over the room. The worst thing is just finding them sometimes when you have, 30 of them launched. The best place to do that is in the park. So we will launch those, and when we're in the park, to be more nature conscious, we usually will launch pine cones. So first they have to do like a treasure hunt for pine cones, and then design their catapult and then launch it across the room. Okay, so the last thing I'm going to do why do I sometimes put on something like this?
To
Protect your eyes.
Protect my eyes. In a lab, most people don't realize obviously, if you're going to do something that's explosive, and we do a lot of explosive things here, or has anyone ever done the soda and Mentos launch?
no.
Okay, if you take a 2-liter bottle of soda and you take a minimum of 5 or 6 Mentos candies and you drop them in the soda, you will get a geyser, sometimes as high as 7, 8, 9 feet, depending on a number of things. But it can't be too cold. That's one of the things we learned. It does not work in the winter outside. So yes, sometimes you want to protect your eyes, protect your clothing, which is why people wear lab coats, and even your footwear. People think in the summer they can wear what they want, but if you're working in the lab, you can't have sandals. Why not? Why can we not wear sandals in a lab?
Because your toes are open, and if the chemicals get on your feet, they can
Exactly.
harm you.
Now, when I was in college, I had to take a chemistry class, and it was on the last day, you had to guess at each station what the chemicals were. And one of the people at the labs, by accident, spilled some chemicals on my shirt. Quickly, I dried it off. By the time I got home, the shirt was full of holes. It ate away at the shirt.
Oh.
So to show you, because we were not, for that class, wearing lab coats. So people are always amazed. It looked just like water, but obviously it was an acid. Okay, so now the last thing we're gonna do. Can everyone see? What do I have in my hand?
A beaker.
It's a beaker with a very tall beak. Let's compare the two.
Like this? Like this?
So
They call it a beaker.
one has a shorter tube, and this one is also a thinner tube. Okay, so we're probably going to do this. I don't know if we'll do it twice. Depends on how it works. So now, what do you think is in the solution? What do you think is in this solution? Looks like the one we had before. Last time we guessed it was water. It is not water. So what else could be this color? Any idea?
Vinegar.
Vinegar. That is correct. So I have some vinegar in here. I'm going to put it on this tray. And I'm going to add, I think this one is going to be You want to see that?
Yes.
And now I'm going to add a little color to it. This time I'm going to use red.
No, see it.
Now, to make it interesting, maybe I'm going to change it a little bit. I'm going to add blue on one side, dripping, and red on the other side. Want to see that?
Yeah.
Higher.
Do you see it, Bayyinah?
No, raise it higher, please. We don't see the bottom. Okay, now yes.
Okay.
So what I was emphasizing is I made a little pattern for it to drip down like that. So now,
I'm not making that hurt.
I've added a funnel to the top of my container, right?
Mm-hmm.
And I'm going to take baking soda. So I think you're going to guess what's going to happen. Guesses?
It's gonna bubble up and explode.
Okay, let's see. And in fact, I'm going to add a little more soap.
Explode.
In fact, I'm going to sit here. I think it'll be better.
We don't see the bottom.
I actually going to get more. Just give me 1 second.
Le firmament a besoin des étoiles pour éclairer la nuit. Ta lanterne.
Face. You have a lot of face.
Nous avons besoin de nos millions d'enfants pour égayer nos jours.
Thank you for the music, Ma.
Hmm?
Thank you for the music.
Yes, well, it's a song for children, saying that we love our children. We want all of our millions of children to stay alive and live well.
Yes. I agree with that.
We don't want nobody coming to reduce their numbers here.
Yes, indeed.
That is so strange. I'm going to try to the other one.
Okay. How about we go on with the conversation?
Okay.
Uh-huh.
So
We
I'm
have,
not sure why that one.
right. Maybe tell us what is a chemical
outcome? Well, anytime you in chemistry, one of the topics that comes up over and over again, I should say one of the outcomes is producing carbon dioxide. So vinegar is an acid, a weak acid, And baking soda, when it combines with an acid, carbon dioxide is produced, and then it starts to fizz. Now, if you do that, adding the soap to it gives it that foamy look. So it doesn't look, it's not one of these quick, hot lava looking things and then it disappears. So if you want it to last longer and it look a little soapy or foam, the real word would be foamy, you would add dishwashing liquid to it. So, and there are tons of chemical reactions that kids can get into and learn about the whys. You know, what do we need to combine with what? So for example, one thing that I want to see, you know, given how many kids understand what is this coronavirus? What have you been told?
It's a respiratory disease.
Okay, good. What is a virus?
It's a sickness that can be lethal.
Okay, like this case, definitely. Now, it's a virus. What they haven't said, make sure everyone's listening to this part, and this is the most important. A virus is strange. It's in that it is considered non-living. If people are so worried about somebody sneezing and the virus is going to land on you, they should be worried. But technically, when you see it on TV, they always show you the ball. It's a ball with spikes, correct? But it's like a ball like this, empty for the most part, and it's made of something called DNA or RNA. So if, for the most part, if it lands and there's no opening, like if you have no opening on your skin, it should, most viruses don't harm you. It only becomes alive when it takes over a cell. So if it gets into your nose, your mouth, or whatever, and it finds a cell, what viruses do, which is very interesting, they don't reproduce on their own. They take over your cell and get your cell to reproduce them. So you become the slave to the virus. And so every time the cell is reproducing, it's really reproducing either both or just the virus. So we need more people like you
Interesting.
understand how a virus works. Because if you notice, historically, every 100 years, there is some big virus. But as we are doing other things to the environment as well, and as you know, there's a whole history behind that, I believe that one of the reasons it takes them so long to solve and find a vaccine is the one thing that STEAM does that scientists don't do. We need diversity. So I'm going to give you the example of how I learned this in my business. When I started Sci-Tech Kids, the very first thing I did was throw a science birthday party for my daughter. I worked hard, everybody had lab coats, everything was organized, and then I forgot the name tags for the test tubes for the kids. And I thought, how did I forget that? But one of the
We are
people in the
losing
room,
you.
excuse me? So one of the people in the room, one of my assistants, has a learning disability. She has ADD or AD, I think it's ADD, not ADHD. And she said, no, I have a solution. You already had their names for the lab coat. Just take off the lab coat and put it on the test tube. And so what I tell people, creativity, innovation happens when you have diverse minds sitting in the room. So although I'm not an engineer and I've learned how to think like an engineer, I always need a biologist, an engineer, an artist when I'm trying to come up with something creative. So I tell kids, when you're on the playground, who do you want to play with? Your friends. But if I'm in a lab, who do I want to play with? Not my friends, because my friends think the way I do. So I need people who do not think the way I do to be creative, because the union of those things is what's going to make us special. So if we want to solve a problem, especially when it comes to a virus like this, as long as there aren't brown or black people at the table, as long as there aren't artists at the table, you just need to have someone explain to the artist how a virus works. And then they'll say, well, have you thought of it like this? That reminds me of this in music. That reminds me of this in art. That reminds me of this in tech. But it won't happen if they're not in the room. So I would love to see, I'm waiting to see who comes up with it and who they had sitting at the table. Or I always encourage people that I meet as an epidemiologist that they need to make sure they have, even among the scientists, a diverse group. Last, I have the same two students. I have one student, I have two students, the one I just told you who had ADD, and another girl, they were both females, who has a very, it's a long story, some other disease. They worked at Rockefeller University, which is one of the top labs, which was where I worked when I got my first job. They only hire a few really bright young minds to do lab research. One of them, well, both of them did amazing work when they would sit in the room with those big time scientists who would even have won Nobel Prize for their work. And they're sitting there trying to solve something. And in both cases, these two girls came up with a solution that none of those other people could come up with, because they were not programmed the same way those people were. And so this is true really for any field, but in science, you see it all the time.
Okay. Let's open up so everyone else, they have questions, they have comments. Let's give a chance to everyone else to participate.
Okay.
All right, absolutely. So if anyone has a question, you can actually just turn your camera on and ask your question, or if you want to raise your hand, I could pick you out and you can ask a question. I actually had a question, Kim.
Okay. Mm-hmm.
You mentioned vaccines,
Mm-hmm.
right? So
Yes.
like vaccines, I know they, you know, I guess they, from what I understand of vaccines, I don't know too much about vaccines, but
Okay.
it's like they take a little bit of the actual like disease or something, and they actually put like other things in there, and they introduce the disease to your body, and then your body naturally builds up like antibodies or something like that to fight them off. But I never understood what were like the other things they put in there in that vaccine, so that it's
That's a very good question. Usually it could be based on how let's say that if it's a virus, as I said, a virus is like the core. It doesn't have much to it. It's very primitive. So sometimes they have to add other components to either give it shape, or to give it stability, or to give it some other components that would work well with a cell in order for it to survive and do its function. So there are a number of things it could be. I think what you may be asking to is sometimes, I mean, I would like to know what those other things are, because you don't know what your body may not react the same way as my body to something. And what if my body is more sensitive? So I don't get the virus, but I get something else. Or I later have a long-term effect or reaction to something else. But the concept of what you said is correct. The virus is, they take a small amount, just enough for your body to develop antibodies, a response to fight it off and destroy it. That's the concept behind the vaccine.
all right. Any other questions? Oh, wait, I got participants that have their hands raised. Okay. Diana, I see you had your hand raised for a while. Did you ask a question yet? I'm sorry.
Hold on, I'm sorry, I forgot to put it down. That was a question I had from Michaela about the forensic science.
Oh, okay. All right, no problem.
Thank you.
Okay,
My bad, I'm sorry.
No problem, no problem. Okay, Marlene, you could go ahead, unmute. Is Marlene still there? You could unmute and ask a question. Marlene going once, Marlene going twice. Okay, let's go on to the next one. Franklin. Oh, Marlene has audio issues. Go ahead. If you could hear me, Marlene, just type your question and then I'll ask Kim, okay? Now, Franklin, if you're there, you can unmute yourself and ask a question, please.
Hi. Do you have any experiments you would recommend for someone who is interested in enzymes and things like that?
Ooh, okay. Experiments. And how old are you?
I'm 12, about to be 13.
Well, okay. The best one I'm trying to think is usually enzymes are a little more complicated. First of all, an enzyme is anything that either brings two molecules together or breaks them apart. So the size of the enzyme, the shape of the enzyme, all of those things are factors in that kind of reaction. So what I can do is there's so many enzyme reactions, but I want you to have something that you could actually see, because most of the ones that I'm how about this? Have you ever done, it's not exactly an enzyme, but this is a fun one. Have you ever seen DNA?
I've seen like pictures of it.
Okay, here's what I'm going to have you do. It has a little bit of an enzyme reaction, but this is something that everyone could try. If you take a strawberry, let's take 3, 4, 5 strawberries, and you mash them. And then you add an alcohol, and I'm going to tell you where you can get that information. And you then take coffee filter or something that will squeeze the liquid through it. In the end, what you will be left with a white, gooey looking thing is DNA. A strawberry is the easiest fruit, in fact, one of the easiest things that you could see living DNA. And that's part of that is soap is breaking it up. You have to add some soap, and then when you add the alcohol, there is some enzymatic reaction. But it's actually a really cool experiment to do. It's one of the few times the average person can say they've actually seen DNA, not in a picture form. So if you want to, I can either send you some information after, or if you Google, it would be just type DNA from a strawberry. And they have a lot of those on YouTube as well.
My daughter just wanted to show this for the girl who just asked. This is her DNA. This is a project that she put her DNA in.
Ah, that's exactly very similar.
Yeah.
And what I'm shocked, it hasn't degraded. When did she do that?
No, not yet. No, and I've had it for quite some time too.
That's unusual.
Yeah.
Usually, it looks like that, and then it starts to degrade. So
right. It's been this way for quite some time. I don't know the components, but she wanted me to show for her who was asking, the young girl who's asking.
Right.
Thank
Now,
you.
where did you get the DNA from? What did she use?
My daughter. This is hers.
No, meaning from a
Where did
strawberry.
you get it?
Okay. So I'm in a class called what's it called? Principles of Biomedical, and we did the strawberry thing, and then we did this. So basically, she made us drink like a Gatorade, and then we switched it around by our cheeks and stuff like that, and then we used the iodine and stuff like that to separate it.
Very nice.
That's DNA. Just to show you guys, so hopefully maybe you could do it too.
Right.
Thank you.
You're welcome.
Thank you. Very good. Thank you so much. All right. So here's Marlene's question. She had audio issues, but Marlene's question was, is there any specific activity for children with ADHD you would recommend?
Usually, for me, I don't distinguish between students for ADHD, because I work with a lot of kids who have ADD or ADHD. The only thing that if I have them, when I notice when they're in a group, depending on their, sometimes their roadblock is if they can't get past a concept, they may have to have their questions answered, or they may have to reread something a few times before they can follow through to the end. But as I mentioned, I work with a lot of students who are ADD and ADHD. I don't think that they need to have something that's different. Because they often bring something else to the table that the other kids don't.
Awesome. All right, very good. Okay, next question comes from Jackie Toussaint. Jackie, you could go ahead and unmute yourself and ask your question.
Hello, hello, hello.
Hi.
My question was more so about, I don't know if it relates, but about carbon, if you can provide any information on carbon, the element.
Well, carbon is unique because it is the foundation of what they call organic chemistry. Organic chemistry means are structures that made of strings or a lot of the letter C of carbons. So a diamond and a pencil are both made of carbons, but how they're attached and then how much pressure is involved, one produces, you get something as amazing as a diamond to something as graphite. So carbon is what they call the foundation or the most versatile element needed to make organic molecules. And not organic as in like organic food, but it's a subgroup of chemicals that it has to have a lot of carbons plus other elements. The other thing about carbon, usually has 4 attachments. So for example, some of the other elements here. It can combine to form single bonds, double bonds, triple bonds. So I'll show you something else. So here, I work with these things called magnetic molecules when I'm teaching kids. This is what oxygen looks like. I don't know if people can see it.
Yes.
And then if they actually structure it properly, it snaps together if I'm doing it right. So this is the shape of water. So here's 2 H's and an O, and it's V-like or bent-like shape. So if I'm using carbon as the center, I can do a lot of cool things with it because it's able to form double bonds, single bonds, triple bonds, and bend in ways that other molecules can't. This is what a molecule of water would look like.
Thank you.
So if you're interested in carbon, there's a lot to learn.
Yeah, I'm trying to figure it out. It's not figured out, but I'm trying to learn more about it.
Learn. Are you in a chemistry class now?
No, ma'am.
Okay.
Yeah, internet information.
Okay. That's good.
Absolutely. All right, very good. Okay, next question comes from Melissa. Melissa, you can go ahead, unmute yourself, ask a question.
Yes, hello.
Hello.
Hi, how are you?
Fine, and you?
I'm doing well, thank you. So I wanted to ask, because I know you said you were based out in New York. Are there any programs for adults, like if they want? Because I in school I actually took forensics in high school and I loved it. And I was trying to get into it.
Waking up, I think.
Hello.
Yeah, go ahead, Melissa. We can hear you.
Okay. Yeah. So are there any programs right now in the city for adults who wanna learn more about science or any forensics type of science, like do experiments and dissections?
There should be. I mean, the same information I gave for the younger person the high school person who wanted to do it. The other place you may want to look at, I'm trying to think the name of these. It's not forensics. There, a lot of places are called maker labs. And so sometimes they have other activities going on beyond just designing or making things. But I would just Google first, because these days there has to be, I don't know of a current one, but a lot of the colleges now offer weekend classes and other type of classes. I would imagine that there has to be some that are related to forensics.
Okay.
And the forensics would probably be under biology, because it could be biology or chemistry, but they would be under those two groups.
Okay, thank you so much.
You're welcome.
All right, we have a question from the chat room. Let's see, are there any homeschooling curriculums you recommend?
Interesting. Well, my daughter this year has been homeschooled, so I'm very familiar with homeschooling. I think the problem though is there's a range. Are you, what grade? May I ask how old?
Let's see, that question came from the chat room. So hold on. First grade.
First grade. Unfortunately, if it comes to science, there's not a lot curriculum-wise for first graders. Again, the school systems, the way they design it, they don't introduce a lot of that science until they're a little older. But so rather than focusing on it by grade level, I would focus by topic. So if she's interested in either science in general or biology or chemistry, I would look at homeschooling programs that have where the curriculum is geared towards a topic more than anything else. Meaning, a biology one or a chemistry one or a general science.
Gotcha.
That's going to be changing rapidly, because if this is the new normal, you're going to find a lot more homeschooling material. The better ones currently are for older kids in terms of homeschooling, not necessarily for the younger ones, unfortunately. Or what I call fluff. It's not as engaging for kids. Not the real science. It's the fluff.
Gotcha. But hopefully it's not the new normal. I'm gonna start sending my kids to your place, Kim, to get home. All right, let's see. We have another question from, is it Le Poupée? I see you got your hand up. You could go ahead and ask a question.
Yes, hi, that would be me, Les Poupées d'Or. Hello, everyone. Thank you so much for this amazing webinar. And thank you, Ms. Magloire, for the presentation. It was really interesting, even though I'm like a 32-year-old adult. I was really into the demonstration.
Thank you.
Yeah. And my question is, I wanted to come back on the 3D printing. I have my company, I make dolls. I make black dolls catered to Black children, where I personalize them and I give them Afro textured hair and Afrocentric clothing, because I want them to have toys that they can see themselves in. And I'm actually considering manufacturing my own doll, but I've been told to consider 3D printing. And
absolutely.
I wanted to know if that is something that is doable, and where should I start, but is there like a certain type of 3D printer that I should consider, or
okay.
Yeah.
What I would do, funny that you should say that. I don't think it's necessarily a different type of 3D printer, but the 3D printers are literally changing every 6 months. The quality, the detail. But if you go on Kickstarter, type dolls, 3D printed dolls,
okay,
you'll see two things. You'll either see companies that are doing something that, I shouldn't say similar. It's made up of people who are making dolls according to what they want. Sometimes it could be superhero dolls,
okay,
or whatever type.
Okay.
And you can see what material they're using and the quality. Or you can go on Kickstarter as a start to type 3D printers for dolls, or 3D printers and dolls, and see which ones have created things and see if you like the quality of them.
Okay.
But I know I supported a company maybe 3 years ago or 2 years ago. They unfortunately didn't make enough money to be supported
Okay.
by Kickstarter, but the quality was really good in terms of that. And the beauty is once you've perfected what you've designed, then it's just a question of producing, and you don't have to have it shipped from China, because China is where everybody produces things. It's cheap.
Right.
But if you want more control of your
my product,
of the design, of the production, and all of that, the only thing that you have to decide is, I'm assuming your dolls aren't very big. If they're normal size, or
yeah, they're the size of a Barbie doll.
Okay, yeah, then you should be able to do that, or partner with a company that would produce it for you, at least in the beginning. But I think that would be a great idea. In fact, that company allowed you to 3D print so you could interchange things. So you could say, I want her to have light brown skin and such, and produce 2 different types of hairstyles so the doll could be changed. So you're not stuck with just one. The person who you're giving the doll to could change the hairstyle based on 2 different hair types.
Okay.
So, but I would definitely consider that. 3D printing moving forward is, and especially because yours is a specific niche, a specific market.
Definitely.
If you want to have control of it.
Yeah.
And if either you buy the right printer or you partner with the company that can produce it just the way you want.
Okay, so partner with the company. I like that. It's not the first time that suggestion came to me. So thank you very much.
So you're welcome.
Thank you.
And why I say Kickstarter to look initially, all the new companies come through there first. Some of them, these days, Kickstarter was originally designed for people who needed the money, but a lot of companies even have the money, but they're using it more for media, for people to know what they're doing.
Okay.
So whenever I'm looking for a new technology, I try to look first on Kickstarter.
Wow, thank you very much. Thank you so much.
Awesome, great. All right, let's see. Next question comes from Brother Kwesi. Kwesi. Go ahead, you can unmute and ask a question.
Okay, my question is, do you have a book available or in the making?
In the making. And what I should say about the better answer is, I have several. Well, I'm an author for books that are already on the market, but through other companies. So I used to work for the Princeton Review. So I have 7 books out on biology, earth science that could be purchased at the bookstore. In my mind, I don't consider them anymore my books, if you know what I mean. It's not they're books that are out there that some of them are 10 years old, for example. But I finished one book that I've written with my daughter about innovation, because I encourage everybody who comes to Sci-Tech to enter contests, because that's where they're challenged to see what they really can do. So Disney, when it came out with this movie called Tomorrowland, had a science contest, and they were looking for 6 kids in the country to say, if you could predict what the future would, if there's a problem in the future and you could solve it, what would it be? And my daughter was one of those 6 winners and won $3,000, a 3D printer, and she met 3 famous people. So we wrote a book about that process, so that kids can be inspired by how do you take an idea, something from an idea to a final product. So her idea was a bee called a bee origami bot, which is a robotic bee that will in the future pollinate flowers, because I don't know if people are aware, we're losing our bees. The bee population is dying. We will not have bees in 50 years.
Wow.
And so people are already working on. So I couldn't hear what you just said.
No, I thought we lost you for a second.
Oh, no. So so I'm working on, but now the other books in terms of, how do I say this? The real way some of these topics should be taught.
Mm.
So last summer I ran a course for chemistry, a chemistry class, and I had only a handful of middle school students sign up, but they were very motivated middle school students who wanted me to go as far as I can in chemistry. We did 1 semester of high school chemistry in 1 week.
Mm.
Wow.
And so those kids, they have such a foundation, but they were also from families, like most of them were Asian. Most of them, the parents kind of said, this is what we want you to do for a week out of all of your different, topics. But, and I say that meaning that they already had the mindset of, I want the foundation now. So when I see this again, I'm not starting from zero. But we need to have more people in our community have the same mindset so that they understand that. But part of it is it was fun. Like the molecule, they spent hours just playing with this. So I would teach them, I have a line in chemistry. I said, the periodic table is your friend. If I can teach you 8 concepts about what's on that table, you should be able to do most chemistry problems just looking at that table, if you understand it. And so once they got that, they were able to turn around and go, okay, what column am I in? Oh, what they were able to figure things out on their own. They were able to build models on their own. And so they'll have an easy time learning or reviewing that subject again. So that's the kind of thing that I'm working on now.
Interesting.
To show kids how to think about it, not just memorizing your way through.
Innovation.
Yep.
The book that you wrote with your daughter, is it a children's book?
Yes, it is.
What's the name of the book?
The Bee Origami Bot.
Can you say that again?
BEE, and then Origami Bot, B-O-T. It's not in the bookstore yet because we're still putting that out. But we've done book readings with, in like at the Intrepid Museum. So we've been invited to. What I like to do again, because I'm a scientist, I test it out to see what kids get out of it now instead of publishing it and then finding out that it's not quite the right level. Like awesome. We need to take that book and have a version that's even simpler for younger kids. That's what we learned from that reading. So they love the concept.
So you're conducting an experiment.
Exactly.
Okay.
Exactly.
Awesome. Thank you.
Well, when you're ready for publishing, I think I know a publisher. Yes, indeed. Okay, so we have one more question. Last question comes from Fran. Fran, you can go ahead and unmute yourself and ask a question, please. Fran, are you there? Fran going once, Fran going twice. Gone. Okay.
Wait, no, don't don't do that to me. I was, it's my laptop. The chat and all that stuff is so tiny on it that the cursor, I have to, no. I have to grow. I have to grow eyes to see it. I was looking up. It had. I don't know how I wound up. Oh, I know what it was. It was that story I told France about. I had this a vision or something that came up in a therapy session, and it had to do with clay, and it reminded me of the other teacher. I'm forgetting your name. You said that clay has been used a lot in healing. Yes. And so I wound up questioning, like you suggested, and I found something that was called Bentonite Clay. And I was wondering what field of science that would be in. And I also saw where they were experimenting with that clay to see if they could like actually program it, because it has almost as many minerals and chemicals that human beings are made up of. It comes from volcanoes.
Ah, okay. And what is the name bentonite you said?
Yes, bentonite.
Right. I'm not as familiar with that, but I know that there are clay has been found to be very important in a lot of in nature and in a lot of ingredients for skin, for a whole host of things. So I wouldn't be surprised at all that
it's
and
spelled,
volcanoes and volcanoes. If you know the whole whether it's people always think volcanoes are just above ground, but volcanoes are also in the ocean.
Oh,
and
okay.
so the chemical formula of what happens and what seeps in and what seeps out also is interesting. So I'd have to look that up.
It was under this website I found called Bentonite Clay Info. It's spelled BENTONITE clayinfo.com. So I mean, when I saw that, I thought, oh my gosh, they're experimenting with this clay to create. They're wondering if they can create basically cyber, like a cyber, like a robot or something, that they're actually experimenting with programming the clay. Anyway, so that was, and the other thing about the bentonite clay is that the base of it has negative ions, but then on the sides it has the positive ions, and the importance of the clay is that it extracts negative, like toxins out. It's really efficient with doing that, and people use it in like baths, and they even take the clay as a potion to rid the body of toxins, because there's something about it that it doesn't affect the person's minerals. It only attracts that. And so when I had it, but that was interesting that it came in a vision that I was having while I was in a healing process of somebody that was doing something negative, and this sort of mask got covered over the person, and then all of a sudden the person became lifeless, and then the clay broke, and out of the clay came out of it was I know it kind of sounds weird, but like souls that this person had captured by their negativity. So it had this sort of metaphysical something that came in it, but that led me to looking up the like the practical science part of it, just how far healing, what have they, the science. So I'm not sure, like what I'm really interested in is what is like the chief science, like what would a category would study?
I see what you're asking.
Come under.
Can I just say thank you for that question?
I would like to add something. Clay is used to heal ulcers. Also, fibroids can be treated with clay.
Yes, and I have fibroid cysts really bad. That was the other thing that I thought was interesting, that this came because I had been searching for years for something that would heal it in a way that wouldn't harm my body.
Right. One of the ways is to have clay mixed with some good water, clean cloth. You wrap it in the spot, you tie it on you. But the key thing is never to put it in your gut. When you remove it, you have to put it far away from you, someplace where you don't go back to, because it does extract whatever causes the fibroids. So If you leave it around you, then it comes right back on you. So
Okay.
when you throw it away, you have to throw it away far from yourself.
Okay.
Awesome. I'm gonna have to go get some clay.
Well,
Clay.
to add to what she said, when I had fibroids, I went to a Haitian woman in the Bronx who's since passed away, but that's what she did. She would use clay as part of her treatment to put on
Not
your
to
stomach.
interject, but I do ceramic arts, and Bayyinah has also told me recently how clay is my weapon. And Fran, thank you so much for this question, because understanding the powers that clay does, and I deal with multiple sclerosis. I didn't even realize I'm dealing with healing just by being on the wheel in that manner. So thank you so much for that. I really appreciate it. Like, I don't know if you realize, but your question spoke to me so much, Fran. Thank you.
Oh, you're welcome. Well, I have to say it was the ancestors. I didn't do it. I just showed up and somehow, but it was but I had it out there as a prayer, you know, for the ancestors to like lead me to something. And I had other healers say, you know, you're going to find something. They felt that I was going to find it. And then this clay showed up and it was amazing.
Very cool. Very cool. Awesome. All right. Kwesi, did you have another question?
Yes, sir, I did.
All
My
right.
question was about the virus. You said that it was non-living. Could you
Yes.
tell us the difference between what is non-living and then what is living?
Okay. It's considered non-living because it's not able to reproduce on its own. It can only reproduce when it invades a host. So every living thing is able, one of the definition of living is it can reproduce itself. Virus alone cannot. And yet in its primitive structure, it's able to do, you know, it can do quite obviously quite a lot of damage when it takes over a host.
I have a different take here. It's not the virus that can do anything. It is when it gets to wherever it gets to. So if you are in shape, there is nothing it can do to you. If you are not what you should be, if you don't take care of yourself. So actually it's, I think somebody said something about it's wherever it lands, it's not it, but it's the landing, the territory that it lands on. So if you care for yourself, if you do the things you're supposed to do, even if it lands on you, there is nothing can really happen. But if you are weak territory, open to all kinds of things, negligent about how you handle yourself, you know, then everything can happen to you with its presence on you. So let us be the knowledge of self. We know that we must have self-control. We must be conscious. We must not gesture without any control of where our hands go, our face go, what we do. And when we have put our hands or whatever to something that is not proper, then we know what to do with it. So with self-control, we can protect ourselves. Taking the proper vitamins, using things properly. That's very important. Otherwise, this non-living thing can kill a living organism because this living organism is very unconscious in the way that it behaves within itself. So I think it's important for us to keep in mind, and certainly no fear. Once you start being afraid, then you can't be logical, then you can't be conscious. There's so much, you limit your power once you are afraid. So gotta deal with that fear so you don't create a territory that is proper for it to damage.
Absolutely.
Or to add to what she said too, even something as simple as understanding, you know, I've spoken to Bayyinah about pH. if you know the pH of a virus and you're able to adjust what you eat based on that, it may not have an outcome on your body because of some basic principles. If it has a low pH and you're eating or you're doing something at high pH, it may not be able to survive or thrive. But that's not the way they're tackling it at this point. It's some more of a, as the concept, we are at war. So it's the warrior concept of we've got to destroy, but there may be a lot of other things that are simpler that we don't know yet, or they haven't explored to say. It's not just what a virus does, but understanding this particular one or a particular one and making whatever adjustments. So that's a lot easier than a vaccine, for example.
Kim is pretty humble. Kim has gone to the White House. She has met with President Obama. Her Sci-Tech kids have something in space. You should be able to tell us more about that.
Okay, we have, as I said, I like to try to encourage kids to be scientists. So whenever I hear of any business, corporation, foundation doing something, I will call and say, we would like to partner with you. And so I found a company that has the capability of sending satellites into space. But the satellites are called PongSats because they're ping pong ball size. So I approached the company and said, I have 100 kids that would like to send it up in space. And they gave us 100 slots. And so each child had their own satellite and they had to do their own experiment to figure out what to send. So some people sent a magnet, some people sent a piece of film. My favorite was popcorn, because when you send popcorn out into space, it can pop and then freeze. So it comes back and it looks like Rice Krispies. And some did work and some didn't work. So some kids were disappointed, but it showed you that you needed to send maybe 10, and 5 or 6 of them worked, but 4 did not. That's the way, science works. So, and that was one of the things that also put us on the map when we met President Obama, because he was impressed that these young kids not only thought about space, but designed something. And then we were able to get it back. They shot it back, so it came back to us. So each child I made write a report to share with the whole group.
Yeah.
That was pretty exciting. And they still have their projects. I still have the extra ones that we had that we sent into space.
Yeah, there's a very cool video on YouTube that shows that experiment, and also the kids being invited to the White House with Obama. It's very, very cool.
Thank you.
Awesome. All right, great. Well, wow, this has been fantastic. Thank you so much, Kim. That was very informative, exciting. My daughter had a great time taking a look at all the experiments and demonstrations. So this was very cool, very cool. I think one thing I would like to see in the future, maybe we could do like a demonstration with a 3D printer, right? That would be
good.
That would be cool if you could like design something, if you guys design something, and we could kind of like see the process, how to get something 3D printed. Because I know myself, I haven't seen a 3D printer in action live, at least.
Okay.
So maybe that's something we could work on in the future.
Okay.
But yeah, this was great. Thank you so much for joining us. I really appreciate it.
No, my pleasure. As I said, it's always great to share that knowledge with children and adults.
Yes.
I say thank you to my little sister.
How would we be able to find you again if we would like to contact?
Yeah, please let me know, like, if you have a Sci-Tech website.
I do.
Or something, I could type it into the chat so everyone could check it out.
Right, I sent it to you in one of the emails, but it's literally scitechkids.com.
Oh, okay, cool.
So, but if it,
everything,
yes, but let me give you, the website is scitechkids.com.
I just typed it into the chat. So
right, but the email has a dash. So the email is, let's just leave it as info@sci-techkids.com. So info@sci-techkids.com.
Is that a dash or an underscore? Or
Dash.
It's a dash. Yeah, I just typed it into the chat room as well. So you guys should have the website and the email if you want to contact. So what do you call? I was trying to figure out. So you're a scientist. So what is is it Dr. Kim or is it?
Well, I've done everything up until from for the doctorate. I just never did the final presentation. So people call me Dr. Magloire. I finished, all the materials for it. And it's funny because I've never felt the need. Some people need the title. I'm not one of those, people, but knowledge and content-wise, yes.
You and your older sister share that same. She's not one for titles either. So.
Right. Well, part of it, I think I've met too many people who the title ends up being more important than the work.
Oh, true. Very true.
And so I only use those things to get where I want to go, put it this way. So, and people ask me, I went to Princeton, so I use that if it opens doors.
Mm-hmm.
But, for that purpose, or some of the, it just happens that some of my closest friends are from there, but it also was luck that they were there when I was there. But I also tell people sometimes a title or a school or whatever doesn't necessarily make you.
Absolutely.
As my mother would say, I was who I was before I got to Princeton. Princeton didn't make me. Princeton added. But if you don't have it before you get there, it's not, it feels like a bigger leap than it should be.
Absolutely. I agree. I've always been uncomfortable with titles because I do so many different things. So it's like, how could you put one title on something? So I agree 100%. All right, great. So, so do we have any parting words? Is there anything you want to mention?
Of course we do. First, we have to say the demonstration that the scientist Kim Magloire gave us, I had asked for 10 minutes and we got an hour and 20 minutes. So, and I'm sure it felt like 5 minutes to her because, that's her life. That's what, So, but it was very interesting. We appreciated that. The one thing that we did not get into, which I really wanted to, is helping people to understand science is part of your life, your everyday life. You breathe in, you drink, you eliminate, everything you do is scientific. Every day, you go in the kitchen, you go cook. She did mention that. The cook is a great chemist. The gardener. There are no activities that have no science in it. So, in fact, we are all scientists, whether we know it or not. Now, the difference is, are you conscious? If you're conscious, then you will know when you are dealing with science. And one of the social sciences is the science of behavior, knowing what you do when you do it. And when what you do automatically does not serve your purpose, knowing what science to apply to change your behavior. When we're talking about knowledge of self, we're talking about the science, the principles that we need so we can be more what we truly are. The science that we need to uncondition ourselves, because our enemies have taken control of our brains and turned us into what we are not. So let us go back. Use the science of the knowledge of self so you can be the divine being that you truly are. That, to me, is the most important science. But all the chemistry, all the everything that is around us is in us. We are a universe. So the astronomy is there, the geometry is there, everything is in your body. Know yourself, and you shall know the universe and all its gods. That's what we do on Tuesday, but that's what's here right now, today, as we receive our esteemed scientist, Kim Magloire, who shared a lot of great knowledge with us. But most of all, remember it's all in you. Have a wonderful week. Till next time.
Thank you.
Thank you.
Thank you so much.
Thank you very much. Thank you.
Yeah.
Thank you.
Thank you.
Thank you.
Well,
And then I said,
All right, everyone. So don't forget.
Thank you.
battle's not over until he's fainted.
All of our young people, thank you very much. You were great.
We're talking about he's not fainted yet, so I'm not.
All right, everyone. I just want to real quick mention that on Tuesday next week will be the third session, April 21st, of the Know Yourself series. So that time that as well. Let's see. Okay. All right, so the Know Yourself series. There were some kids having some.
They were great. They were great.
They were.
My little girl had an awesome time, like participating and all that stuff. So thank you, Kim. She always wants to do science experiments. In fact, she wanted me to help her build a bridge using marshmallows. So just want to remind everyone about the Know Yourself series. And of course, this is sponsored by Thoroughbred Books. Purchase your books, thoroughbredbooks.com. And again, thank you for everyone for your donations to help us keep all of the things that we're doing going. And thank you again to Kim.
Yeah, yo.
Wow, appreciate
tapped in again. She went in on behavioral science.
Yes.
That's awesome.
Absolutely. So thank you, everyone. We're going to go ahead and wrap this up, and we'll see everyone on Tuesday. All right. So thank you, Bello. Thank you, Kim. Thank you, everyone that joined us.
Hold on 1 minute, please. Hold on. Listen. On Tuesday, work it out. I want 300 people, no less. On Tuesday, 300. Thank you.
All right. So we got our homework. Invite your friends, invite your family, get everybody on this next webinar on Tuesday, 1 p.m. You need 300 people to attend.
Everybody invite
it's going
10
to be a
people.
powerful message. It's going to be something that you don't want to miss. So be sure. I mean, we got the word from our mother, our queen mother, asked us to get 300 people. So we can't, what are we going to do? Can't say no.
Invite 10 people.
All right, very good.
All right.
All right, thanks everybody. Have a great day. Stay safe. Wash your hands. And we'll see you soon.
All right.
Take good care.
All right.
Well.